Hi guys, and welcome to another video. In this video we're going to be looking at calculus graph interpretation. We're going to be looking at a question from the February-March 2010 paper, and in that particular paper, let's read the question. It says the graph below represents the function f and g. So there's two functions given to us. F is a cubic function and g is a straight line function, g of x equals to x minus 2. A and minus 1 and 0 are the x-intercepts of f. The graph of f and g intersect at A and C. Let's have a look. So as you can see here now, we've got the graph of f, which is a cubic function, and it's turning on the x-axis. Now what happens when a graph turns on the x-axis? Where your turning point and one of your roots basically is the same coordinate. Well, what we need to do in that particular case is that particular factor, or rather that particular root now, or the factor, becomes x plus 1, remember, but it's going to be squared. Okay, so the root is x equals to minus 1, so the factor is x plus 1, but it's squared because the root and the turning point share the same point. Now we also got A is an x-intercept as well, and as we can see here in the first question, it says determine the coordinates of A. Now remember, A is an x-intercept. It's an x-intercept of the function f, as you can see, the function f there, and function g both intersect at point A. But we are given that g of x equals to x minus 2. Therefore, to find this particular coordinate, all we have to do is take x minus 2 and equate it to 0. Therefore, x equals to positive 2. So for A, it's positive 2. 0. Alright, so we can write that solution down for the coordinates of A. The coordinates of A will be 2 and 0. Now if you want to show some working, well, let's write it here. The solutions 11.1 x minus 2 equals to 0. Therefore, x equals to 2. Therefore, A is 2 and 0. Alright, so that's 11.1. 11.2, show by calculation that A is 1 and C is negative 3. Now this is called graph interpretation, basically finding the equation of a cubic function. Now let us look what we are given in this particular question. We are given the x-intercepts. So you are given that A is 2 and 0, and you are given this x-intercept which is negative 1 and 0. And when you are given the x-intercepts, we're going to use the following formula. Well, let's just look at what else we are given. We're given the x-intercepts and we are given one point, which is the y-intercept. So when you are given the x-intercepts and 1 point, you can use the following formula to find the equation of a cubic function. So we can say f of x. So in this particular case, let's just write down the formula. Y equals to A into x minus x1, x minus x2, x minus x3. Remember, a cubic function can have at most 3 roots. Therefore, now for the point, we're going to substitute, remember, x and y. So that point that we're using is 0 and negative 2. So that particular point is, let's say P for point, right? 0 and minus 2. So wherever we got x and y, you put for x you put 0 and for y you put minus 2. And once again, you got your roots. So we've already written that down. So my roots are negative 1 and positive 2. Therefore, my factors will be x plus 1 squared. I've explained why it's squared, because your turning point and your root share the same point. And here, this particular factor will be x minus 2. Remember, the root is x equals to 2. Factor is going to be x minus 2. So let's write that down. So as you can see here now, we've got the following. So firstly, we're going to now say minus 2 equals to A, and we got our factors. So we'll write down x minus 2, x minus 2. But what is x? We'll say 0 minus 2 and 0 plus 1 all squared. 0 plus 1 all squared. Now let's solve for A. So we got minus 2 equals to minus 2 times 1 is minus 2a, minus 2a, therefore a equals to 1. So a equals to 1, so we are on the right track. There they say show that a is equal to 1. So now we need to show that c is equal to negative 3. And in order to show that, now we are going to resubstitute a equals to 1 into the formula, y equals to a, but this time we are not going to substitute x and y, but we're just going to substitute x minus 2. So we're going to substitute our roots. Basically, we're going to put our factors in there, x minus 2, x plus 1 all squared. And all you need to do now is just open up these brackets. 1 into x minus 2, x plus 1 all squared. Let's open the brackets out there. So that will give us x squared plus 2x plus 1. 1 x minus 2, so x times x is x cubed, plus 2x squared plus 1 minus 2x squared minus 4x and minus 2 equals 2. Let's simplify. 1 x cubed plus 2x squared and minus 2x squared both cancel. X minus 4x is minus 3x and minus 2. Now you'll notice that I've been carrying down this 1 all the way through. Okay, that's very important. According to BODMAS, I have to simplify, open out the brackets first before I can do any multiplication. So brackets before multiplication. Now I'll take this 1 into the brackets and it doesn't have any effect. But the point is that you cannot ignore this particular multiplication. You're only going to do it in the end. Okay, now it would have an effect if, let's say, this was negative 1 or even 2. So the answer is x cubed minus 3x minus 2. So the function now is f of x equals to x cubed minus 3x minus 2. Therefore, a equals to 1 and c equals to minus. Let's check that out. Right, a is 1 and c is minus. There you go. All right. Determine the coordinates of B, the turning point of F. Determine the coordinates of B, the turning point of F. So, in this particular example now, for turning points, remember that we have to find the derivative of the function and equate it to 0. So there's my turning point here. And remember, your turning points are your local maximum or local minimum. And what happens at your turning point? The derivative of your function, remember, from maximum and minimum values, the derivative of your function, f prime x, is going to equals to 0. Okay, so all you need to do is take the derivative of the function and equate it to 0. So let's write that down. So for 11.3, determine the coordinates of B. We're going to say f prime x, f prime x equals to 0. Therefore, derivative of the function. So the derivative of the function will be, well, we've already worked it out, and there's it right here. So it'll be 3x squared, 3x squared minus 3 equals to 0. Now we're going to solve for x. So as you can see here, 3x squared minus 3 equals to 0. We take out 3 as a common factor, we'll be left with 3 into x squared minus 1 equals to 0. 3 into x minus 1, x plus 1 equals to 0. Therefore, x minus 1 equals to 0. Or x plus 1 equals to 0. Remember, if you divide by 3, this 3 will just cancel out, right? Or 0 divided by 3 is 0. So therefore, the coordinates, the x values of your turning points is x equals to 1, x equals to minus 1. And that makes perfect sense because, as you can see, one turning point is here. And you can see that it's minus 1 and 0. So no need to substitute there. So for minus 1, you know that one turning point is minus 1, 0. But remember that they asked you for the turning point of B. So all we need to do now is substitute back into the original equation. So therefore it will be y equals to, original equation is 1 cubed minus 3 times 1 minus 2. And that will give us 1 cubed is 1 minus 3 minus 2 equals 2. 1 minus 3 is minus 2 and minus 2 is minus 4. Therefore, B is 1 and negative 4. So B is equal to 1 and minus 4. So let's go back on the graph. Let's see if that makes sense. Right, that makes perfect sense. 1 and minus 4. So B is 1 and negative 4. Okay, so let's just write that neatly. B is 1 and negative 1 minus 4. Let's answer the next question. In the next question it says, show that the line BC is parallel to the x-axis. So show that the line BC is parallel to the x-axis. Okay, so let's just see if we can clear some of this up here. All right, now, okay, so that means that this particular line BC show that it is parallel to the x-axis. All right, now how can we show equal to each other? Now we know that this line over here is a horizontal line, so the gradient is equal to 0. So if we can find the coordinates of C, and if we can show that the gradient of BC is equal to 0, and remember the gradient of BC will equals to 0 if it has the same y coordinates, right? If it has the same y coordinates, then the gradient will be 0. But how can we find it? As you can see here, the straight line goes through this cubic function at 3 points. So therefore, we're going to be finding intersection points here. So all we need to do is, we need to take the two functions f of x and equate it to g of x and solve for x. So in this particular question, 11.4, we're going to be equating both of these functions together. So 11.4, we're going to say f of x equals to g of x. Now we already know the function for f of x, and f of x is equal to x cubed minus 3x minus 2. X cubed minus 3x minus 2 equals 2, and g of x is equal to, and that function was given to us, and there's it here, x minus 2. So that's going to equal to x minus 2. So we're going to equate it x minus 2. So let's now factorize. Well, first, before we factorize, we have to now simplify. So minus 2 and minus 2 on both sides would now cancel off. So we're going to be left with x cubed. If we bring this x over to this side, it will be minus 4x, and that will equal zero, x equals to minus 2, x equals to positive 2. So this one here will be at negative 2. So the one here at C is going to be at minus 2. Now we need to find that y value there. Remember, B was minus 1 and 4. So what do you notice about C? It lies on your straight line, and the straight line is y equals to x minus 2. So let's now go and solve for that particular value. So y equals to x minus 2. which is minus 2, minus 2, minus 4, minus 4. So therefore the coordinates of C is minus 2 and minus 4. Minus 2 and minus 4. Coordinates of C is minus 2, minus 4. Now we already know that the coordinates of B is minus 1 and minus 1 and minus 4. So minus 1 and minus 4, minus 1 and minus 4. Therefore, the gradient of BC is equal to minus 4 minus minus 4 is 0 over minus 2 minus minus 1. So we're going to get 0 regardless. And remember that the gradient of the x-axis is also going to be 0. Therefore, BC is parallel to the x-axis. So BC now is parallel to the x-axis. I think now that answers our question. Show that BC is parallel to the x-axis. So we show that the gradients are equal, therefore the lines are parallel to each other. Alright, so let's look at the next question, 11.5. Now in 11.5, you got find the x-coordinate of the point of inflection of F. Remember that the point of inflection is F double primed x equals to 0. Alternatively, you can find the x-coordinate of the point of inflection by averaging out the x values of your turning points. So another way is minus 1 plus minus 1 over 2. That will give me 0 over 2 equals to 0. So the point of inflection here will be x equals to 0. The other way of finding it out is to find the second derivative and equate it to 0. So for 11.5, let's have a look at that. So 11.5, the second derivative, and we need to equate that to 0. Now, if you look very carefully, we'll be able to see that we have already found, well, we've got there we go. So the first derivative is 3x squared, where's it here, minus 3. So therefore the second derivative will be 6x equals to 0. Therefore the second derivative will be 6x equals to 0. Therefore x equals to 0. Or the other way I told you can find the x-coordinate of the point of inflection is to average out the x-coordinates of your turning points. 2. Therefore in this case, the point of inflection here, by using this method, will also give us x equals to 0. Alright? Next question. So for 11.6, write down the values of k for which f of x equals to k will have only one root. Let's go back and look at our curve. Okay, so if you look at the curve, it says for what values of k. Now the k value that they're referring to is the y value of your turning point. Right? That's the value that we use to actually answer this question. Now for one root, it means that that line k must only cut the graph at one place. That means it must only cut it at one place. So therefore, if you look at this particular y value of your turning point, therefore k must be greater than 0. So it must be greater than this turning point, or k must be less than this turning point here, which is minus 4. So 2. Right? So the solution for this question will be k must be greater than 0. And the reason that k must be greater than 0, if k is greater than 0, it will only cut f at one place. And if k is less than minus 4, it will only cut f at one point. Okay, so once again, the solution there for 11.6 will be k greater than 0 or k less than minus 4. So k greater than 0 or k less than negative 4. Okay, the last question that we've now come to is write down the values of x for which f prime x will be less than 0. So the derivative of this particular function, where will it be less than 0? So if you look at this particular, where will it be less than 0? So remember the gradient here is going to be positive, here will be negative, here will be positive. Remember that if you draw a tangent here, you will get a positive gradient. If you draw a tangent here, you'll get negative and positive. So where is it, which values of x will it be negative? -1 and -1. So the answer is between -1 and -1. And that's positive 1. So between -1 and +1. Between -1 and +1. That's the solution. Alright, so this question is on graph interpretation. Alright, so once again, remember learners, if you haven't subscribed already, subscribe to my YouTube channel, which is JR Maths.